Now that we have a way that's much more mathematically useful for measuring and describing angles, we're going to use this concept to define what are called our 6 trigonometric functions. In order to define these functions, we must first agree on some terminology. Consider a right triangle, must be a right triangle, with some angle theta inside. We're going to refer to the legs of the triangle in reference to that angle theta. So for example, this leg will be the opposite side. The leg here would be the adjacent side, and here will be the hypotenuse. Notice if theta changes, the opposite and adjacent switch, and the hypotenuse would stay the same. We now define our 6 trigonometric functions based on this with what's called the sine of theta being the length of the opposite leg divided by the length of the hypotenuse. The cosine of theta is the adjacent leg divided by the hypotenuse. And the tangent of theta is the opposite leg divided by the adjacent leg. If you've done anything with trig before, you may have heard the expression SOHCAHTOA, and this helps you remember sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. These 3 trigonometric functions lead directly into the other 3, the first being cosecant, which is 1 over sine, which is hypotenuse over opposite. The next is secant, which is 1 over cosine, or hypotenuse over adjacent. And last but not least, cotangent, which is 1 over the tangent, which is adjacent over opposite. These 6 trigonometric functions we can use for certain calculations. For example, suppose that we have a triangle with this being theta and these sides 3 and 4. First of all, we can figure out the hypotenuse using the Pythagorean theorem. We know that 3 squared plus 4 squared is going to equal c squared. This gives us 25 equals c squared, or the hypotenuse length is 5. From this, we can then calculate our 6 trigonometric functions. Sine is opposite over hypotenuse, 4/5. Cosine is adjacent over hypotenuse, 3/5. And tangent is opposite over adjacent, 4/3. And then these lead directly to cosecant is 5/4, secant 5/3, and cotangent 3/4. Just to point out, this is one of what's called our special triangles. If you have sides of length 3, you have what's called a 3, 4, 5 triangle. And this can also relate in terms of ratios, if the ratio of the sides is 3, 4, 5. Let's look at another example here where all we know for a different triangle is we have a right triangle, and we know that this angle is theta over 6. I'm sorry, pi over 6, and this angle is theta. Because we know that our angles have to add up to 180 degrees or pi radians, we have that we know then that this angle, since we have pi over 6 plus our right angle pi over 2, finding our common denominator, we have pi over 6 plus 3 pi over 6, leaves us with 4 pi over 6, or 2 pi over 3. That tells us that this angle theta must be pi over 3. From our previous ratios that we looked at, we know then that our side ratios are 1, 2, and the square root of 3, because we have a 30, 60, 90 triangle if you're thinking in terms of degrees. So again, we can now use these ratios to find the sine of theta, square root of 3 over 2, cosine of theta, adjacent over hypotenuse 1 over 2, tangent of theta, square root of 3, and then our cosecant 2 over square root of 3. Secant is simply 2, and cotangent is 1 over the square root of 3.